Hello everyone, my name is Zhou He. I'm a senior engineer from AI Lab in NetEase. I will give an introduction to our solution for the shared task of LongSumm2021. First, let's define the long summary task and focus on the challenges. Researchers often summarize scientific articles by writing a blog, which requires specialist knowledge and deep understanding of the scientific domain. Most of the document summarization tasks focus on generate a short summary that keeps the core idea of the original document. For long scientific papers, a shorter abstract is not long enough to cover all the salient information. Furthermore, models like BERT is limited to memory and cannot deal with the long input encoding and long output decoding. The long summary task is proposed to address such problems. Data description. For abstractive summary, data consists of blog posts created by researchers that summarize scientific articles. And for extractive summary, data is based on video talks of associated conference. We have 700 abstractive summaries and about 2,000 noisy extractive summaries. Abstractive summaries length varying between 100 and 1,500 words, and extractive summaries length is on average around 1,000 words. Now let's review the previous works. The extraction model extracts several sentences and words from the original article by the semantic analysis and sentence importance analysis. The abstracts obtained by the extraction model can better reflect the focus of the article, but because the extracted sentences are scattered in different parts of the article, the coherence of the abstract is a problem. And the abstraction-based models are based on the structure of sequence-to-sequence and pre-training, like BERT and T5. For this task, the model is limited due to memory and time consuming. Most of the previous models are session-based and have two problems. Session-based model may drop some important information among the sessions. And only use one type of model for prediction cannot make a good use of the advantages of different models. So we ensemble the two types of methods. Our solution consists of 4 steps. Step 1, session generation. We split a document into several sessions with a certain size and use a logic metric to match the ground truth summary sentence. Step 2, abstractive models. We train abstraction-based models, Big Bird and Pegasus. The Big Bird uses a sparse attention mechanism that reduces the quadratic dependency to linear. The Pegasus is a pre-trained model, specially designed for summarization. Step 3. Extractive models. We train extraction-based model, including text rank, DGCN, and LongSumm. Step 4. Ensemble. For each type of model, generate the summary for answer 1 which has the best performance. Finally, use an ensemble method to merge the summaries together. We construct training data like this. First, select the appropriate session size and buffer according to our experience. Second, segment long paper to sessions. Third, assign summary sentence to sessions. For abstractive model, the corresponding summary sentence is assigned to each session according to the Lugin metric. In order to make the model predict long summaries as much as possible, a greedy matching rule is used. For extractive models, just match sessions with corresponding summary sentence. To solve the problem of long text input, we use the sparse attention structure, the big bird. And two open source pre-training models are compared. The Pegasus is selected according to our experimental results. Furthermore, the model is pre-trained on archive dataset to improve ability to generate abstract. We tried 3 extraction models and finally select a DGCN extraction model according to experiments. We thought the advantage of DGCN extraction model is that it can process the information of every sentence in the text at the same time and identify the important sentence by context. The abstractive model can produce different expressions from original text and is more fluent, but it cannot guarantee covering all the key points. The extractive model can capture most of the important information, so we ensemble abstractive and extractive models to further improve the abstract. Reorder the abstracted and extracted sentence according to the sessions like this. Then, drop repeated sentence according to similarity. The longest one will be reserved. Finally, use task rank to select the most important sentence as abstract. Experiment details setup. We do some basic pre-process as there is a lot of dirty text in the data extracted by science parser. For example, merge broken words and remove words not in word list and replace URL links with URL symbol. Based on the test results, the best abstractive models and extractive models are built with parameters like this. According to the leaderboard, our result is far superior to other models. We believe this is because our ensemble method not only removes the redundant sentence in the combined summary, but also makes the output output of extractive result will supplement for the result of abstractive result. We notice that the abstractive result recall score is much lower than FE score. We thought the reason might be that the abstractive result is shorter than ground truth. Here, the extractor model means only use extractive, and the SBAS abstract means we only use abstractive model. And finally, the ensemble result means we ensemble the both type of models. In conclusion, we proposed an ensemble method based on session for long summary task, and we experiment several abstractive and extractive models. One of the biggest problems is how to reduce the resource consumption for the transformers structure model. BigBird, proposed by Google, solve long text input through sparse attention mechanism. However, BigBird do not solve the problem of long text output. So, our future work will focus on how to decode longer text so that the language model can adapt to more NLP scenarios. Thank you for your time.